Now I'm going to start the class. So this is Math 2621 probability for application, class 7, mean and variance. Okay, so please allow me to make this full screen. Okay, so the last time we learned about geometric distribution, and this is the last topic under chapter 1, which is mean and variance of a random variable. Okay, so before, without spending much of the time, let's go to the next slide. So if I draw the distribution function, okay, so this is the one way I can draw a distribution function of a random variable. Okay, so let me write down for the discrete case. So if it is a discrete random variable, we can construct corresponding histogram and then find the distribution of the random variable by connecting the midpoints and connecting these points using a smooth curve. So we can obtain the density curve. Okay. So after you draw this density curve, so using the mean, we can measure the center of the distribution. So it's measure the center of the distribution. Okay, so there are some situations you can see skewed data sets like skew to right or skew to left. Okay. So in this case, the center is not going to be exactly middle. Center will be somewhere here. Okay. So in here, the center will be here. Okay, so if you have a long tail or a long right or left tail, then center will be towards to the tail. So that's how the expected value is. That's how we can show expected value. And one more thing, there are a few more terminologies we can use depending on the application and the field where we using this expected value concept. We will use different terminologies for the expectation. One word is we will use mean, average. Average is the most common one. Okay, average and expected value in probability. The mean is more commonly used when we are doing statistical subject. Average, we will use some kind of business application, and expected value we will use in the probability or abstract classes like this. Okay, so if it is asked to find average, mean, expected value, those are everything same. Okay, so now let's see how we can find the expected value of a random variable. Okay, so this is the definition of expected value. The expected value of random variable x, mean of x or expectation of x or average of x is denoted by E of x and defined as in this equation. Okay. Okay, so expected value also denoted by mu. So this is a Greek letter called mu. So we can use mu also denote the expected value. And you can bring this one into your cheat note when you are doing exams. Okay. So I will explain what this notation means. So this will be very important to understand then, because we will use this one several times in this class. So this whole thing is called summation. And please note, this is the lowercase x and this is the uppercase x. Okay, this is uppercase x means a random variable. The lowercase x means the value of a random variable. Okay, so this is the value of the random variable. Okay, and finally the last part. Okay, so the last part of this one is, this is the probability of x equal x. So that's mean the probability of x when large x, so the random variable takes the small value x. So this is the probability. Okay, so that means we will multiply the corresponding outcome of the random variable with its probability and then take the summation after multiply. Okay. Okay, so let's do a quick example to understand this formula. So in this case, if you play roulette and bet $1 on black, and then you will win $1. Okay, with probability 18/38, and you will lose 1 with probability of 20/38. So now I can write down the probability mass function of x. So x can take $1 or negative $1, because we are losing means negative, and probability of getting x equal 1 is 18/38, and this is automatically 20/38. Okay, so this is the probability mass function of x. Now let's use the equation and find the expectation. So expected of x is equal. So I would recommend, I would like to recommend here, you write down the equation first before plugging. This will automatically help you to memorize these equations. Okay, now I'm going to plug here. So x value first is 1/18/38 plus. Okay, I will plug first and then write down. But when you are doing this one in exam, you can just multiply. Okay. First, I have to take 1 times probability of 1 plus minus 1 times probability of minus 1. Okay. Now I'm going to plug here 1 times 18/38 minus 1 times 20/38. So the answer will be negative 2/38. Okay, so you can leave your answer into the simplified fraction form, which is negative 1/17. I mean negative 19 over negative 1/19, or you can write down the decimal form, which is 0.526. Okay, so what's this mean? Okay, so your expected value is negative, so that means we can expect a loss. Okay, we can expect a loss. Okay, So that's mean if we play repeatedly, we will lose eventually. Eventually. Okay. Okay, so let's do a quick example. Find the expectation of the geometric distribution with parameter p. Okay, so this is just for exercise to feel the geometric distribution as well as the expectation formula, but I'm not going to ask this one in your exams. Okay. Okay, so let's write down the geometric distribution, and let's say x follows a geometric distribution with parameter p. So then we can write down the geometric distribution, probability mass function of x, 1 minus p to the power x minus 1 times p. X goes to 1, 2, 3 all the way to infinity. Now let's start with the formula. Expectation of x, which is sigma x px. Okay, now I'm going to plug. Okay, I will plug here 1 times. So this is the first value you can take for your x. 1 times p of 1 plus 2 times p of 2 and so on to the infinity. And now I'm going to plug 1 times probability of 1 means you have to plug 1 for this equation. So it is 1 minus p to the power 1 minus 1 p plus 2 times 1 minus p 2 minus 1 times p plus 3 1 minus p 3 minus 1 p plus I will write down one more 1 minus p 4 minus 1 p all the way to infinity. Okay. Now let's write down this one with simplification. And each term has p common, so I'm going to take p out. And here, if I simplify, I will just get 1. And the second term is 2 times 1 minus p, 3 times 1 minus p square. Here 4 times 1 minus p cube, and all the way to infinity. And here, this is a expression with infinity number of terms. So I will denote it by S infinity. Okay, so now here we need one more fact. Okay, from your math class, infinite geometric sum. Infinite geometric sum, which is given by from this equation. Suppose S infinity equal a plus a r all the way to infinity. Okay, I will write down one more term, a r square all the way to infinity. So then we can write this, we can find this the summation by a first term over 1 minus r. R is the increment if r is between 0 and 1. Okay, so this is we are going to use this fact, okay, and find the value. So we can write P Okay, so here I'm going to write this one as S infinity, which is 1 plus 2 times 1 minus P all the way to infinity. Okay, I will write more terms. Okay, 3 times 1 minus P square. Dot, dot. And I'm going to take this one as my first equation. I'm going to multiply 1 minus P, first equation. Okay, I'm going to take the first equation. Take the first equation and multiply by 1 minus P. So then I will get, in the left hand side, I will get S alpha times 1 minus P equal here 1 minus P, first term, second term 2 times 1 minus P square. Okay, so I will remove this fact now, otherwise I don't have enough space. Okay. Okay, and plus 3 times 1 minus P square all the way to infinity. And I'm going to denote this one as my second equation. Now let's subtract second from 1, 2, 1 from 2, okay. 1 minus 2. So I have S infinity minus S infinity 1 minus P. So if I subtract from 1 with something, I don't have anything to subtract with 1. 2 times 1 minus P minus 1 minus P, I have 1 minus P remain. And 3 times 1 minus P square and 2 times 1 minus P square. So then the remaining thing is 1 minus P square. So the next remaining thing is 1 minus P cube and so on. Okay. Okay, so from the left hand side, it remains S infinity minus S infinity plus P times S infinity. So these two cancel. And here 1 plus 1 minus P plus 1 minus P square and so on. So this is the infinity many geometric sum. So this summation is same as one over first term is 1 and the increment is 1 minus P. So it is 1 minus 1 minus P. Okay. Okay, so then I can show P S infinity is equal 1 over P because 1 minus 1 cancel and minus times P is make plus P. So P is subscript infinity equal 1 minus P. So then I can find this is has 1 minus P square. Okay. So from that one, I can show this is P times 1 minus P square. So that's mean 1 over P. Okay, so that's mean the expectation of geometric sum is 1 over P. Okay, so and now on, if you want to find the mean of a geometric random variable, you can use this results. Okay, so feel free to use this result. You don't want to prove. Okay, so in this class, you can use this results without proof this one. Okay, you don't want to prove like this. You can use 1 over P as the expectation of random variable when x follows a geometric distribution. Okay, so hopefully that makes sense. Okay, now I'm going to discuss few more notes related with expected value. Okay, so first note is expected of a function of a random variable. Suppose, so here we have just x. Okay, so expectation of x. But if you have a series of random function of random variable, so this should be uppercase x. So if this is a function of random variable, so this is a function of random variable. So if you want to find the expectation of function of random variable, you can use this definition. Okay. So for example, if you want to find Ex square, so this will be important. So you can find this expectation by using x square here. So if you have found some function of x, you will use the same function as it is and p of x. Okay. So in another example, if you want to find x cubed, so then it should be x cubed here, probability of x. Okay. So that's how you can find the expected value of a function of a random variable. Okay, so let's do an example. Here this says this is another way we learn this one. Another way to give the probability mass function. This is using piecewise function form. When x equals 0, I have this probability. X equal 1, another probability. X equal 2, I have another probability. And question asks to find Ex square. So the equation will be Ex square. E of x square equal sigma for all x square dx. Okay, now I'm going to substitute this one. First substitute 0 square p of 0 plus 1 square p of 1 plus 2 square p of 2. Now find this value by plugging 0 square. Probability of 0 is 1 over 16 plus 1 square is 1 times probability of 1, which is 6 over 16 plus 2 square 9 over 16. Okay. So now you can use the calculator to find this answer. So you will get 21 over 8. Okay. So you cannot simplify this one further. So I'm going to leave this way, or you can put it in the decimal form, but please use 4 decimal places. Okay, so both answers are accepted. So that's how you can find E of x square. Okay, so the another note about the expected value. So the expectation is an linear operator. Okay, so here expectation, this is a linear operator. Okay, so if you plug, so in here, this is a function of linear function. Linear because we have the largest power of x is 1. So that's why it's a linear function. So this is a linear function of a random variable. It's same as this is a linear function of expectation. So in other words, you can move this expectation inside without changing anything. Okay, so we will prove these results, but I'm not going to ask this one in your exams, but it is better to know. Okay, so we can prove this one using the definition of expectation. So I'm going to write this one. Okay. Okay, so this is the definition for this one. X, here ax plus b, p of x. Okay, so don't forget this should be, this is the uppercase x and here is the lowercase x. Now what I can do here is I can distribute this p of x here in both places. So all x, ax, p of x plus b, p of x. Now I'm going to take the summation for the each term separately. So I can write expectation of x, ax, px plus b, px. Now since this is a constant, I can take this one from outside for the expectation, because this a and br does not depend on x. So I can take those one outside of the summation. Now check this one here. This should be 1 because p of x is a probability mass function. If you take the summation of the probabilities of the probability mass function for all x, you should get 1. Okay, so and this is the definition of E of x. Okay, so then that means we done with the proof. Okay, as the last step, we can write a ex plus b. Okay, that's the end of this proof. So let me save more place here so then I can write down this clearly. So here I'm going to take sigma same time here and take a outside from here. Okay, so here it will be a sigma x xpx, a b sigma px. Now this will be 1 because P of X is a probability mass function. So this will be 1. That means we can write A, and this is the definition of EX plus B times 1, which is 1. B times 1, which is B, okay. So that is the end of. Okay, yeah, we did the proof, okay. Okay, so the third note about the expected value. So suppose there are a series of random variables x1 to xn. Okay, so there are more than one random variables x1 to xn, and a1 to an are constants. Okay, so then I'm going to multiply this a1 with x1, a2 with x2, a3 with x3 likewise. So this rule means I can take the expectation here without any doubt. Okay, so if I expand this one, this is something it says, okay, a1 x1 plus a2 x2 plus all the way to an xn is same as, I will write here, is same as a1 ex1 plus a2 ex2 all the way to an exn, okay, plus an exn. So that's what this means. Okay, so that's mean you can bring this expectation inside. Okay, so specifically, if you take a1, a2 all the way to an equal 1, all the these are 1, then you can, it's like you are bringing, you are finding this one. Okay, so it's like x1 plus x2 all the way to xn equal ex1 plus ex2 all the way to exn. Okay, this is true for n number of random variables. Okay, so those are the required notes you need to know about the expected value. So first of all, you need to know how to find the expected value for the probability mass function. And then probability mass expectation is a linear function, so you can move it over the linear combination of random variable. And how to find the expectation of function of a random variable, this definition. Okay, so those are the important thing about the expected value. Okay, so then the last part of the this lecture, which is variance. Now let's learn about the variance. So although mean measure the center of the data set, variance will measure the spread of the data set. Okay, so it will spread the distribution. It's measure the spread of the distribution. In other words, I can say variance is measure the spread around the mean. Okay, it will measure the spread around the mean. Okay, consider this example. Suppose we have a bulb 1. Okay, so mean lifetime is 1000 hours with variance 1000, and bulb 2 has mean lifetime 500 hours with, okay, let's take it's also 1000. So also 1000 hours with variance okay. Okay, so my question here is which bulb you will pick. Okay, so which bulb, which kind of bulb you are going to pick here. Okay. You will buy. Okay. Okay, so you can answer this question in our discussion form. Okay. Please answer this question in discussion form. I will post this question after the class. Okay. Okay, so now let's see the definition of and how to find the variance of a random variable. So this is the hardest definition actually. But I will provide easy way to find the variance. Okay. So first of all, let's understand this one. Here we have an expectation. So variance of x, also we can denote this one by sigma square. Okay. Or another, there are some cases we can denote this one by v of x, but this is the most common one. Or yx is the common one. So E, expectation of, here you have two terms, x minus, this is the mean, okay, E of x. So you have to minus first and then square it and then take the expectation. Okay, so this is the mean, okay, mean of expectation. And here Ex is a known value when finding variance. Okay. In other words, if you ask to find the variance without mentioning anything, you have to first find the mean or the expected value and then find the variance. Okay. So first of all, you have to find the expectation and then find the variance, because we need to use expectation to find the variance. Okay. So we measure the spread around the mean. Okay. So now I'm going to provide an easy way to find the variance. So this is the easiest or the simplest equation you can find the variance. Okay. The previous one you can use, but it is little complex. So it is easier than, this is easier than the previous one. So you can use Ex square, you know how to find this one. And this is the mean square. Okay. So find the Ex square minus the mean square. So then you can find the variance. I'm going to prove this result as well, but I'm not going to ask this one in your exams. Okay. So variance of x, this is the definition, E of x minus Ex, everything square. Okay, I will use different color to the outside brackets, so then it will, you can easily differentiate. Okay. And different color, this one as well. Okay, so first subtract the mean and then square it and then take the expectation. Okay, so from the definition of expectation of function of random variable, so we can take this one as g of x. Okay, now what I'm going to do here is I'm going to write down the definition for this expectation, which is x minus e x square p of x. Okay, so this is expectation of this one. So this is a function of random variable. So this is the definition. Okay, I will write down the definition here. E gx is same as sigma x gx px. So this is the definition I used to write the second step. Now I can expand this one, sigma x x squared plus, sorry, so this is a binomial term, so you know how to expand this one. So minus 2x ex plus ex everything square, and outside of this one I have p of x. Now I'm going to move this p of x here, p of x here and here, and same time I'm going to move the summation as well, like this, sigma x x squared px minus 2 is a constant and e of x is also constant because we have to calculate it before calculating variance. So I can take these 2 and ex both outside of the summation, and I only need to have x px. Okay, so this would be little x. And the last term, ex square sigma x px. So again, the last term, this will be 1, because if you take the summation all over the probabilities, you should get 1 because p of x is a probability mass function. And from the definition, we can write this one as e x square. Okay, so this part is going to be e x square minus, this will be 2ex, and this part will be ex as well, ex everything square is the last term. Now you can see we have ex square. If you simplify this too, because this is, you have ex times ex, which is ex square, 2ex square plus ex square, which is ex everything square. That's the end of. Okay, so you don't want to worry about proof this results. Okay, you can use this results when you are doing simplification. When we are doing binomial expansion, I use this rule. Okay, so a minus b square, which is a square minus 2ab plus b square. Okay, so another note about the variance. So variance of ax plus b, we can write ax square plus a square times variance of x. Okay, so I'm going to prove this results. Okay, so this is a linear combination. So this is variance of x is so this is not a linear operator. So that's why you cannot take only variance inside and without changing a and b. Here, when you are taking variance inside, your a should be square and your b is vanished. Okay. So now I'm going to prove this results first. Okay. So from the definition, I can write. So from the previous rule, okay. ax plus b square minus e ax plus b, everything is square. Now I'm going to simplify this one. Keep e in outside and expand this one. So a square x square plus 2abx plus b square. And I'm going to take this e inside here by keeping this square outside. A e x plus b, because expectation is a linear operator, so I can bring it inside. So I bring this one inside without making any changes. And I expand this one by keeping expectation outside. The next line, I'm going to bring this expectation inside. Okay, so this is a square, ex square, plus here 2ab, or all are constant except this x term, plus expectation of b square is just b square, minus 2a, minus aex plus b square. Okay, so let's expand this one as well. We don't want to go another step. Minus, I'm going to expand this one, a square ex everything square minus 2ab ex minus b square. Now let's cancel the like terms. Here 2abx cancel, b square cancel. So the only remaining things are a square e of x square minus a square e of x everything square. So this means I can take a square out. So then ex square minus ex everything square. So that means a square, whole of this part I can write variance of x. So this is again variance of x. This bracket is the variance of x. Okay. So I have a square times variance of x. So that's the end of the proof. Okay, so this means if you have the distribution like this, okay, if you have the distribution like this, and this has a variance of x, and if you move this one up or down, if you move up or down, okay, so if you move this one up or down, the variance is not going to change. Still, this has the variance of x. Okay, so that's the meaning of this beta. Okay, so if you add or subtract b and find the variance, this does not change anything to your variance. Okay, your spread is not going to change. That's true. Okay, here if you see the spread here, if you move this one, this curve up or down, your variance, the spread is not going to change. Okay, so this is the spread, it's not going to change. So that's the meaning of adding plus b or minus plus b. It doesn't change your variance of the random variable. Okay, so the standard deviation of random variable is the square root of the variance. Okay, so after you find in the variance, you can find the square root, and then you will get the standard deviation of x. Okay, so this is also can be denoted by sigma. Okay. Okay, so there's a reason we can find this. We have to find the standard deviation. That's because the unit. Okay, So if you find the expectation, the units will be the same unit has the random variable. Okay? Units are same as random variable x. If you find the variance, units are square. Okay, we can say square root of the random variable. If you find sigma, this again has the same same as the random variable. So that's the main reason we are finding the standard deviation. It has the same unit as your random variable. Okay, so for example, let's take UX has unit has inches. So then the mean or the expected value has the unit inches. Sigma square has square inches. And sigma has again inches. Okay, so same as for any other units. So that's the reason we are finding, that's another reason we are finding the standard deviation. Okay, so now I think that's a good time to do an example to understand these concepts. Okay. Okay, so let X be the amount of memory of purchase in a flash drive in gigabytes. The probability mass function of X is given in below. Find the mean and the standard deviation of the following distribution. Okay, so we asked to find expectation and variance of the distribution. So let's find the mean first. Expected value of X. By the definition, it is X, Px, which is 1 times P1 plus 2 times P2 plus 4 times P4 plus 8 times P8 plus 16 times P16. Now plug 1 times 0.05 plus 2 times 0.10 plus 4 times 0.35. So you're multiplying these two and multiplying these two, multiply these two, and so on, and then take the summation. 0.4, 16 times 0.1. So your mean and variance can be any real number. Okay. So this will be 6.4500. Okay, you can use the calculator to find this answer. Okay, so let's find the variance. So when finding the variance, I will use the simplified form, okay, which is Ex square minus E of X, everything is square. Okay, so this is I already find in the previous slide here. Okay, I only need to find this E of X square. So E of X square is same as from the definition X square Px, which is 1 square P1 plus 2 square P2 plus 4 square P4 plus 8 square P8 plus 16 square P16. Now plug 1 times 0.05, 4 times 2 square is 4, times 0.1. I will keep 2 square as it is here, because you can plug the equation for the calculator. You can plug it, you can input it to the calculator as it is and find the final answer. First one, 16 square 0.1. Okay, so you will get this answer as 57.2500. Now we can find the variance of x, yx, which is 57.2500 minus 6.4500. Okay. Actually, you don't want to have this 0, okay. Okay, so the final answer is, don't forget to, you have to square this one. Final answer will be 15.664. Use your calculator. 6475. Okay, so be careful in this step. Sometimes you will forget. So that's the most common mistake you can do. Okay, and question says find the mean and standard deviation. So we have find the mean and variance. Now let's find the standard deviation. Standard deviation is the positive square root of the variance, which is square root of 15.6475, which is 3.9557. Okay, so be careful with when you are doing this question. Sometime I will ask to find variance. Sometime I will ask to find standard deviation. So check whether it is asked to find variance or standard deviation. Okay, hopefully that makes sense how to proceed when you have a probability mass function, how to find the mean, variance, and standard deviation. And the last example, if you have a geometric distribution, we prove this results. Now you can use it. Expectation will be 1 over p, and variance will be 1 minus p over p square. Now, suppose in this example, it says p equal 0.2, find the expectation and variance. So expectation is 1 over p, which is 1 over 0.2. That means this is 5. So 10 over 2, which is 5. And here, 1 minus p over p square, which is 1 minus 0.2 over 0.2 square. This will be 20. Okay, and you don't want to prove these results, you can use it right away. Okay, so don't attempt to prove this one when I'm asking mean and variance of geometric distribution. You can find it directly by substituting to these equations. And one more last question, if you want to find the variance standard deviation of the random variable which follows a geometric distribution, just find the variance first and then take the square root of it. Okay, so here, okay, so this definition is not going to change. Okay, so if you want to find the standard deviation, just find the variance first, find the variance and then find the square root of the variance. So then you will get the standard deviation of the random variable. So in this case, it is 20 root, which is 4.4721. Okay. Okay, so that's all for this lecture and for this video. And this is the end of chapter 1 as well. So in the next video, video 8, I will start chapter 2, which is counting technique and more probability distribution functions. Okay, so in next class I will start counting technique. That's very important and interesting topic in this course. So then I'm looking forward to meet you in my video 8. Since then, take care and have a good one. Thanks for your attention. Bye.